All right, the next one, trigonometric equation. I am not sure, they did not give me an interval how I was supposed to solve this. I think I have two equations though, right? Yeah, so let's do this one between 0 and 2 pi. So it's common when we're doing solving trigonometric equations that we'll either have an interval or it'll say find all solutions. Now in this one we have a sine and a cosine, and typically guys, just like with quadratics, when you have sine and cosine on the same side, basically what we're going to want to do is get them to the same side, set it equal to 0. We don't want to divide by sine of theta on both sides. We don't want to divide out our functions, right? We're trying to solve for our angle theta. So we don't want to be dividing on both sides. That's not going to be a proper technique. So I am just going to solve or subtract a 2 sine of theta equal to 0, sorry. Now you can see that both these equations, they share a sine of theta. So, you can kind of think about this like a 4x and a y, like a y squared. Like you can factor out the sine of theta. They share them in common. So I'm going to, oops, not a 4. And actually they share a 2 in common as well. So let's factor out a 2. Sine of theta. And by factoring out 2 sine of theta, that's going to leave me with a 2 cosine squared of theta minus 1 equals 0. Now I can go and apply the zero product property, right? I have a product times another, or sorry, a product of two expressions equal to 0. So now I can set them both equal to 0. And therefore 2 cosine squared of theta minus 1 equals 0. So again, this is just a scalar, so that's not going to change anything. And then here, that's going to give me, now this one's interesting, cosine squared of theta equals 1/2. But remember, we need to undo the squaring, right? So we're going to square root. And again, since we're introducing the square root, we need to use plus or minus. So that is going to be plus or minus. Now, again, that's going to be 1 over the square root of 2, which ends up being square root of 2 over 2. So again, that's a plus or minus square root of 2 over 2. So to find the solutions, we need to go back to going to the unit circle, right? So basically we're saying, the sine of what angle is equal to 0? Well, between 0 and 2 pi, there's two angles. Like here's the unit circle. When is sine equal to 0? Well, 0 and pi, right? And again, that includes 0, but does not include 2 pi. So you can see the y coordinate point on the unit circle is going to be true for at 0 or equal to sine of that angle is going to equal to 0 at 0 and, so I'm going to use set notation. So 0 and pi. Then I say, for what all the values is cosine of theta equal to plus or minus the square root of 2 over 2? Well, cosine, or all square root of 2 over 2 for the x-coordinate, is going to be all of these angles, which is basically, pi over 4, 2 pi, 3 pi over 4, right, at that point, 5 pi over 4, and 7 pi over 4. So, those are your angles. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I don't know why I used a parenthesis there. And that's just another horrible bracket, but we'll just roll with it.